Hello everyone, Jai Hind to all. Welcome in digital studio of Ajay Kumar Garg, Engineering College, Ghaziabad. Today in this video lecture, I am going to discuss about stack. The topics of stacks are, which is discussed here is definition of stack, in which we will discuss about what is stack, how stack is implemented, and how the stack is working in a linear order. The second topic is application of stack. In application of stack, we will discuss in which position we logically stack is used for performing the different types of operation, which may be programming, which may be a conversion of arithmetical or logical expression. Third topic is stack as an ADT. This is the most important topic of the application of stack. Next one is basic operation on stack, then representation of stack. In representation of stack, we will discuss about two types of stack representation. The first one is array representation and second one is linked list representation. Then next one is algorithm. Here in terms of algorithm, we discuss there are two types of algorithm. The first one is push algorithm and second one is pop operation, pop algorithm, which is mainly used to implement the stack. And last topic is array implementation of stack. Basically, there are two methods are used to implement the stack. The first one is array and second one is linked list. But here we discuss about array implementation of stack. Now we discuss what is the definition of stack. Stack is the linear data structure in which insertion and deletion are allowed only at one place, one end, called the top of the stack. The order may be called LIFO, last in, first out, or FIFO, first in, last out. Here the terms we use linear data structure. Linear data structure means data is stored in a contiguous memory allocation. That means we take an example of the array like this. This is array in which we want to store the data. Then we store first position, then second position, then third position, then fourth position, and so on. This order is called linear collection of data elements. Linear means contiguous storage of data. That means each data is connected with previous as well as next element. That means each data is connected with two nodes, previous and next. But in case of non-linear data structure, we have discussed each node is connected with more than two nodes. The non-linear data like graph and tree, and in linear data structure we discuss array, linked list, stack, etc. Stack is implemented by using array and linked list, which is the main data structure of the given data structure, and by using these two data structure, array and linked list, we implement each type of linear data structure. The next topic is the representation of stack, how the stack is represented inside memory. This is the basic concepts which is represented in memory. The top is called top of the stack. We have using a variable, the name of the variable is top, which represent top of the stack. That means if we want insert an element, here we call insertion as a push operation and deletion is called as a pop operation. If we want to insert an element into the stack, we push onto the top, and if we want delete an element, we pop from the top. Between middle and top, we can't do operation between them. We perform any operation on the top of the stack. This is the basic concepts of stack. That means insertion and deletion only at the one position, and that position is called top of the stack. The next topic is application of stack. In application of stack, the first point is used for evaluating the value of expression. The value of expression means we have given a arithmetical expression and we want to find the value of the given expression. Then we used stack to find or evaluate the value of given expression by using stack. The next one is used for infix to postfix conversion. This is the most important topic in application of stack. By using stack, we have to convert an expression which is given in infix. Infix means if the operand comes between the operator, then the expression is called infix expression. Such type of expression is converted into postfix or prefix by using stack. Third topic is used for infix to prefix conversion. That means infix expression is converted into prefix. In case of prefix, operators come before operand, and in case of postfix, operators come after the operand. Okay. Then this representation is called postfix expression, and this expression is called prefix expression. In both cases, we have to use stack to convert an infix expression into postfix or prefix. The next use is used for function called recursive. Like calculation of factorial of a number or recursive implementation of a function, we use stack to call in main function by using stack. Used for backtracking. Backtracking is the main concepts of compiler, in which we use stack to convert or process the given string by using backtracking, or construct a tree by using backtracking methods. Next one is used for reverse the string. If we have the string like A, B, C, D, and we want to reverse this string, then we use stack to reverse the string. The output generated like this. The output generated like this: D, D, C, B, A. And this operation is performed by using stack. The next one is used for matching tags in HTML and XML code. This is the page development programming concept, in which we have also used the application of stacks. Now, the next topic is stack as an additive. This is the main topic of stack. Here, when we define stack as an additive, then we are only interested in knowing the stack operation from the user point of view. We know about how the application is working. We don't go how the process is implemented. Only know how this is working. We not knowing how this is implemented. This part of the stack is called additive. Means we are not interested in knowing the implementation detail at this moment. We are only interested in knowing what type of operation we can perform on stack. That means only interested by using the function and what type of function we want to perform. We don't go how this operation is performed. There are ready-made function which is used here to perform the particular operations. The next topic is basic operation on stack. The first operation is push operation. This operation in case of array we known as insert, but here this operation is called push operation. That means if we have a stack and we want to push or insert an element, then call push function and which insert a element into the stack like this. The first element come inside the bottom, then the next element on the first, and then we have to insert next element. Second operation is pop operation. Pop operation is used to remove an element from stack. As we know, operation perform in case of stack, operation perform at the top of the stack. When we insert an element, the elements comes on the top of the element, and if we want to delete an element, the top element is deleted first, then second top element deleted next, and so on. We perform insertion and deletion here. The next operation is pick operation. This is the pick operation, and it returns the top value of top element without erasing the value. That means if we want to print B without removing B, this returns the value of B or the value B. The next one is empty. Returns true if stack is empty, else false. That means this function is used to check our stack is empty or non-empty. Next one is full. This is also used to find the stack is our full or empty. And last one is size. This function return the size of the stack. This is the main operation of stack, in which we mostly use push and pop. Push is insert the element into the stack, and pop is remove the element from the stack. These two main operations used in case of implementation of stack. This is the diagram which show how the push and pop of the item to be performed. If we want to push an item into the given list, then we insert like this, and if we want a delete element from the list, then we perform operation like this. That means pushing from top and removing from top, and each operation must be performed at the top of the stack. Now, this is the main topic of stack. Here we discuss how the stack is represented inside the memory. That means how the stack is represented inside memory by using two methods. The first one is array representation of stack, and the next slide we show linked representation of stack. But here we want to show how diagrammatically stack is represented inside the memory. Here a stack may be represented in memory in various ways. There are two methods. The first one is array representation of stack. In array representation, we used one-dimensional array to represent the array in memory. This is the stack ARR array, in which the bottom element is 0 and the max stack contain the whole size of array, and one more variable top, which contain the address or index of top element. That means there are here we use three variable: bottom, top and max stack. Max stack contain the maximum size of array which is declared initially, and top contain the top element address index of top element which is inserted inside the array, and bottom contain the index value of first element. By these three variables, we have to access or modify the given array by using stack concepts. Now, if we want to insert an element inside this stack, or we want to delete an element from this stack, we must insert this position or delete this element. That means operation performed at top. Top is this position. If we want to delete the element, then first we have to delete DD, or if we want to insert a new element, then we must insert at this position. In next slides, we show how the insertion and deletion to be performed logically are by using program. Here we only show the diagrammatical representation of array. The next one is linked representation of stack. In linked representation of stack, we use singly linked list to represent the stack. The last point, last node is called bottom node, which link part is null, and the head point to the first node is called top of the stack. That means if we want to perform a insertion and deletion operation, then we must perform at this place. If we want to perform deletion operation, then we must delete this node, or if we want to insert a element, then we have to insert at this position. When we insert a node at this position, this node point to the first node, and this node is pointed by head, and then we have to insert data at this place. This is the link representation of stack. Now the next topic is algorithm. Algorithm is the list of steps which is used to solve a particular problem. Here we want to show how the push operation is work logically. That means if we want to insert an element into the stack, first we have to check our stack is full or empty. If our stack is full, then a condition is arises. The condition is called overflow. That means there is no more space to insert an element. If our stack is empty, then first we have to increment top by 1, and then we have to insert item at the top position. Initial condition of the stack is like this. We take a stack like this. This is the initially empty. Top is the variable which contain -1. If we want insert an element, first we check stack already filled. At this condition, if top equal to max stack, then print overflow. Otherwise, we have to increase top by 1. That means top equal to top plus 1. That would be 0. -1 plus 1 gives 0. Now this position is 0, this is 1, this is 2. At this place we have to insert an element. Next element to be inserted at this position, then next element is inserted at this position, and so on. We have to insert an element into the given stack. This is the algo for push an element to the stack. That means we first increase the value of top by 1, then we have to insert the value, then increase the top by 1, then insert an element into the given stack. By so on, we inserted the coming element into the stack. The next algo is for pop of the stack. Pop of the stack, we here take stack is the variable that is the name of array. Top is a variable which contain the location of top of the stack and item which we want to delete. That means in case of deletion, when an element is deleted, that element is stored inside a variable. This procedure pop the top element from stack and assign in the variable item. That means a deleted item must be stored inside a item for future reference. Step first, stack has no item to be removed. If your stack is already empty, at that condition the stack is underflow. The condition is top equal to -1. I already saw if top is equal to -1, that means your stack is empty, and this condition is for underflow. This condition is for underflow. अगर ऐसा नहीं है then set item equal to stack top. If it is not empty, then we have to delete top element and assign inside the item, then top equal to top minus 1, then we have to return. In case of push, first we have to increment top by 1, then we have to insert, but in case of pop, first we have to delete top element and store inside the item, then we have to decrease the top by 1. This operation is used to delete an element from the stack. Now we talk about array implementation. There are difference between implementation and representation. Representation means how inside the memory the structure is constructed, how the data is represented. But in case of implementation, we show the programming part of the array implementation. Here we take an array. The logical concepts of array is we insert or delete at any position from the stack, but we want to construct this array as a stack, or we want to implement condition to that this array work like a stack. At that condition, we know that stack ARR is an array and insertion and deletion of operation can be performed at any place, but we want to stack AR we have like a stack. At that condition, we have to set certain rules which is implemented on array. Hence, the insertion and deletion must be performed at one end called top. For this, we will keep a variable top which will keep track of the last inserted element or topmost element in the array. By using the top variable, we keep the track of the top element where we inserted the element or we deleted the element from that position. This is the structure of a empty stack in which 0, 1, 2, 3, 4, 5 and top is also null. That means top contain the minus 1. And now to indicate that stack is empty, we will put minus 1 in the variable top. That means we write like this, top equal to minus 1. This condition tells us that our stack is empty. Now the top equal to 0 indicate that top element is at index 0, and this means that there is only one element in the stack. If top is equal to minus 1, there is no element in the stack. If top equal to 0, that means there is one element in the stack. This condition is basically we implemented at the time of designing of stack. Now this is the conditions where we want to push an operation. For the push operation, top is incremented by 1. Before this slides, we have show you how the algo of push or pop operation to be work. Here we show how the implementation part can be take place. Initially, when we want to push an element, I discuss first we have to increment top by 1. That means top equal to top plus 1. Then at this position, we have to insert an element. This is written here, top is incremented by 1. Then new element pushed at the position top. After incremented the value of top, we have to insert a element top at the top position. This is the series of push-pop operation in which we can show how the element is inserted or deleted from the given stack. Now initially the stack is empty and the initial condition is top minus 1. That means there is no element inside the stack. If we want to push a single element, and that is 1, we want to push 1 in the given stack. First we have to increase the top by 1, then what is the value? Top equal to top plus 1, top equal to the top contain initially -1 here. So we will write like this, -1 plus 1, the top equal to 0. That means top contain 0. Now at the 0 position, we have to insert this 1. First, we have increment the top, then at that position, we have to insert element 1. Now, we want to push 3. In this condition, we also first, we increment the top, top equal to top plus 1, top now contain 0, then top equal to 0 plus 1, top equal to 1. Top is set by 1. At 1 position, we have to insert 3. The next, we want to push 5. Then first, we have increased the value of top by 1. Top is now containing 1. 1 plus 1 equal to 2. Here, the top contain 2. At second position, we have to insert the value 5. Now, we want to push 7. Now, increase top equal to top plus 1, top equal to 2 plus 1, top equal to 3. This value assigned to here, and at the position 3, we have to insert 7. Now, we want to push 8. Then top equal to top plus 1, top equal to 3 plus 1, top equal to 4. 4 contain here, and at the fourth position, we insert 8. The next one is, we want to insert 11. Then top is also increment by 1. Now the top contain 5. 5 contain here, and at the fifth position, we have to insert 11. And so on, we insert 12 at the last position. At this condition, the top contain 6, and the value of 6 is 12. Now, if we want insert one more element, at that condition, the overflow condition is arises. There is no more position in the stack. Stack is already filled. Hence, if we want to insert or push 13, at this condition, overflow condition is arises. This element is not pushed inside the stack because stack is already full. That means top equal to max minus 1. At that condition, the value of top is equal to the maximum size of stack. The stack size is 7, and here the top is also 7. So we does not insert any more element inside the given stack. Now, this condition not possible. There is not enough space in the stack. This state is called overflow state, and the new element cannot be pushed inside the stack. This condition is called overflow condition. Now, we want to perform pop operation. In case of pop operation, first we have to decrease the value of top by 1. Then we have to delete the given element. For the pop operation, the element at the position of top is deleted and top is decremented by 1. First, the element to be deleted, then we have decrement the value of top by 1. In these conditions, here we want to show how the deletion operation perform inside the stack. I have 6 elements and the top contained 6. We want to pop. In case of pop, there is no need to take value in case of pop. We only write pop function. The top element is deleted. Here, if we want call first time pop, then the element at position 6 is deleted, and then the value of top is decreased to 5. Top equal to top minus 1, 6 minus 1, the top contain 5. Now the second pop is called, the 11 is also deleted and the top assign the value 4. Then again we call the pop function, the next element is also deleted and the top contain 3, and so on. We have to delete the given element one by one. Now this is the part where we discuss how the programming is done in case of stack. We take a header file, hash include studio.h, and second one is int stack arr 4. This is the size of array. That means size of stack, the maximum size of stack is 4, and this type of declaration is called global declaration. We can use this place, we can use also a second type of declaration like hash define preprocessor directory. That means hash define max 4, and here we declare like this, int stack underscore arr max. This type of declaration is also we used here in place of this code. We want to show the next slide. This is the push operation code. This is the programming part of the implementation. Now we want to push an element into the stack. At that condition, we tell you first we have to check overflow condition. At that condition, top equal to max minus 1. This condition is tells about overflow. If this condition is true, print overflow. Otherwise, we have to increment top equal to top by 1 and then push data at the top position. That means, look at this point. This is the stack. This is the 0, 1, 2. We have already pushed A and B. We want to push another element C. Then where the C is comes, the value of top is 1. The value of top is 1. First we have to increment top equal to top plus 1. That means top equal to top plus 1, 1 plus 1 equal to 2. Now stack arr top, that is 2, equal to C. Here we have to insert a element C. This logic is repeatedly called and we have to insert the given element into the stack. But the size is dominating factor. If the size of the array you decide is 4, then we have to only insert 4 element. If we want to insert 5th element, the condition is overflow. So the size of the array is, or the size of the stack is initially decided by the programmer at the global declaration section. This is the pop operation code. In case of pop operation code, here we take a variable int value. Value is the variable which is used to store the deleted elements, but the initial condition is that when we want to delete an element and stack is already empty, at that condition overflow is arises in the condition of push, but in case of pop, underflow condition is arises. If elements already exist in the stack, then we have to use this operation to delete the element. Value is equal to stack arr top, then we have to decrease the value of top by 1 and return the value. The deleted element is stored inside the value, which may be used in the future operations or future need. This is the function which is used to display the content of stack. We use simply a loop int I equal to 0, I less or equal top and I plus plus. Now we use a simple printf function to print the content of array stack arr by using this for loop. Now we want to show the main function of this code, the main function of this code is hash include studio.h hash define max 4. That means the size of the array is, the size of the stack is 4. This is the structure of your stack. We have only 4 space to insert or delete the element. In top equal to -1, this indicates that the value of the top -1 is indicate that our stack is empty. Here the main function, we want to push 2, the first element is inserted. Then we want to push 5, the second element of inserted. Then we want to push 6. Here they want to push 9. Here the 9 is inserted. If we want to push one more element, that would be 13. This element is not pushed inside the stack because our stack size is only 4. So this arises overflow condition. When we want to push this element, overflow condition is arises and this element is not pushed inside the stack. In the same process, we have to call the delete and display function. Delete means pop and display function. If we want to print the content of the array, only 2, 5, 6 and 9 would be printed. That means if we call here display function, only this 4 element is printed. At the same place, at any place we have to call delete operation. If a single time delete operation, a delete function is called, a single elements to be deleted. If multiple time delete operation is called, multiple element is to be deleted. That means if we call here pop, then one element 5 is deleted. If here call second time pop operation, second element to be deleted, and so on. We called pop and display operation sequentially one by one. If we call push, then element to be pushed inside the stack. If we call pop operation, element to be deleted from the top of the stack. And if we call display operation, display function, the content of stack will be displayed. This is the introduction part of the stack. Thank you everyone.